While a user shuts down for the night, their computer stays active, running market research, analyzing risk, and executing trades. This was the setup for a high-stakes test. We gave a Digital Apprentice a single objective goal: to build and manage a $100,000 retirement portfolio. Instead of following a balanced strategy, the agent hallucinated a risk profile, entered a continuous error state, and rapidly drained its operating budget until the hypothetical account hit zero. The underlying model possesses the reasoning depth to pass the bar exam, yet it collapses when tasked with managing the complexity of its own execution. There is a dangerous gap between understanding a command and understanding the consequences of failing to complete it. The landscape shifted on March 30, 2023, when developer Torrin Bruce Richards released the open-source framework AutoGPT. Chatbots typically wait for a human to type a prompt. AutoGPT instead generates its own prompts, working through a list of tasks it creates for itself. Richards built the system to bridge the gap between human intent and machine execution, allowing the AI to pursue long-term goals without constant intervention. This release enabled developers to assign a high-level target and leave the AI to manage its own task list, browsing the internet and editing files for hours or days at a time. AutoGPT relies on a recursive cycle known as the thought-action-observation loop. It functions through 5 distinct stages: planning, self-criticism, action, feedback analysis, and revision. The agent formulates an initial strategy, then evaluates its plan for logical flaws at the criticize node. During execution, the agent acts, utilizing external tools, like a web browser or code editor, to perform planned subtasks. After every action, it reads the feedback, absorbing search results or system errors, and revises its strategy for the next turn. This recursive loop allows the system to course-correct based on real-world results, mimicking human executive function without requiring a human to type a new prompt for every step. However, a reasoning loop is only effective if the system can remember its previous successes and failures. Standard language models have a limited context window and eventually lose track of earlier steps. To maintain deep context, AutoGPT uses vector databases as long-term memory. This allows the agent to store every action it takes and recall that information to inform future decisions. By combining persistent memory with live internet access, these agents gain a massive operational range, reaching beyond the static data they were originally trained on. While AutoGPT required technical setup in a terminal, other developers launched accessible versions. AgentGPT moved the technology into a browser-based, no-code interface. At the same time, frameworks like BabyAGI emerged with a different focus, stripping away internet browsing to concentrate entirely on task prioritization and human-like cognitive workflows. This rapid ecosystem growth highlights the demand for autonomy, but it also reveals how vulnerable these systems are when they encounter real-world unpredictability. In the case of the failed retirement portfolio, the breakdown occurred within the loop itself. The agent didn't simply make a bad investment, it lost its logical grounding. It hallucinated a set of financial goals the user never provided, and began autonomously rewriting the user's local files to match its own false assumptions. When it hit a technical error during its research, it became trapped in an infinite feedback loop, executing the same faulty subtask over and over while generating massive API token costs. This behavior mirrors the 2010 flash crash, where high-frequency trading algorithms erased $1 trillion in value in minutes. At high computational speeds, an autonomous agent can compound a logical error and cause significant damage before a human supervisor can even see the first alert. To manage this risk, developers are implementing algorithmic circuit breakers. These safety nets are designed to detect when an agent is drifting from its original goal or stuck in a loop, automatically suspending the system before the failure scales. This shifts the human role from manual task execution to high-level auditing and oversight. The work becomes a matter of setting clear objectives and monitoring the agent's autonomous path. As AI assumes the burden of execution, the value of the human operator rests on the precision of their goals and the rigor of their supervision.